inverse functions. So I've taken a very simple mapping diagram up here, and I've just put the domain 1, 3, 5 and 7, that's the elements of the domain, and the range in the codomain is 4, 7, 10 and 13. Now the definition of a function is that when you input a set of x values, you'll get an output of a set of y values, okay, and that's called your range. Now, so the couples from that are going to be 1, 4, 3, 7, 5, 10 and 7, 13. Okay, so that's the couples from that particular mapping diagram. Now, if you work backwards and go from the range back to the input, or from the output back to the input, you end up with what's called the inverse of a function. So the inverse, if that there is f of x, then the inverse of f of x is going to be 4, 1, 7, 3, 10, 5 and 13, 7. The inverse. Now, from the notes, you can see there that a function has an inverse only if it is bijective, okay? So it has an inverse only if it's bijective. So remember, the definition of a bijective function is a function that is both injective and surjective, okay? Remember, an injective function, the input will have a unique output, and a surjective function, the range will be equal to the codomain. Now, look at this little piece in your notes here. Take the function f of x equal to x squared, and take these two couples, 2, 4 and minus 2, 4. So if you find the inverse of those couples, you see that they are 4, 2 and 4 minus 2, okay? So they're the inverse couples. Now if you look at those, f inverse is not a function, because you end up with 4, 2 and 4 minus 2. Your inputs are the same, and remember, the definition of a function is that your input, you can only have your input giving you one output, okay? So it's not a function, as the input 4 does not have a unique output, okay? So therefore you could also conclude that f of x equal to x squared is not bijective, and it doesn't have an inverse, okay? So just recapping, the inverse of a function, okay? A function only has an inverse if it is bijective. And remember, you, to find the inverse, you're just working the opposite way. You're working from the output back to the input, okay? So an example down here, f of x is equal to 5x minus 3, and you're asked to find f dash of x, okay? So if f of x is equal to 5x minus 3, find f dash of x, okay? So the first thing that I would do here is I would call f of x y, so y equals 5x minus 3. And what I'm going to do is I'm going to rearrange for x. So y plus 3 is equal to 5x. X is equal to y plus 3 divided by 5. Now, to find f dash of x, what you do is, remember, you just change your values around. So you'd have your output and then your input. So instead of everywhere you see y, you're just going to replace it by x, and that will give you the inverse. So my inverse, f dash of x, the dash being the inverse, is x plus 3 all over 5. Okay, so what did I do? I got x on its own, and then I said f dash of x, the dash being the inverse, equals, and all I did was exchange my y value with my x, or exchange my y with my x. Now in part 2 of this question, I'm asked to prove an important piece of information, that f dash of f of x is equal to x, okay? So just bring your attention to this tiny little diagram up here, okay? This little diagram shows a coordinate diagram, okay? Your x and y axis, okay? And in that diagram, this line here is f of x, okay? And this line here is f dash of x, okay? and your to move from your f of x to your f dash of x, it's always reflected in the line y equals x. And that's what I'm going to show here, is that if you do f dash after f of x, you'll always end up with x. Okay, so f dash of, this is going back to our composite functions using the same techniques, f of x, and we know that f of x was 5x minus 3. Okay, and we're trying to prove that's equal to x. So we have f of x is equal to x plus 3 all over 5. F dash of x of 5x minus 3 is equal to 5x minus 3 plus 3 all over 5. So you can see there you're left with 5x all over 5, which leaves you with x. Now you can prove also that the exact same will happen if you use, or if you do, f of f dash of x will also yield you x, because remember, back to that little diagram, one line is got by a reflection through the line y equals x. Okay, so in this one here we're going to do f of f dash of x. Now we already know that f dash of x is x plus 3 all over 5. Okay, so f of x in the question is 5x minus 3, so it's f of x plus 3 all over 5. So everywhere we see x, we replace it with x plus 3 all over 5 and take away 3. So you end up with your 5's cancel, so you're left with x plus 3 minus 3, and the minus 3 and the plus 3 cancel, so it's equal to x. So remember, f dash f of x is the exact same thing as f dash of x, because when you look at your coordinate diagram, okay, and if this is your f of x line going through here, so if that's your f of x line, your f dash of x line would be somewhere here, and remember, it's reflected through the line y equals x, and that is true for all inverse functions. Now another example on inverse functions is at the top of the handout on the next page. The diagram on the right shows the reflection of the curve f of x equals x cubed plus 1 in the line y equals x, as I've just explained. So here's your curve f of x, and here's your f dash of x curve here. Okay, find f dash of x. Okay, so very simply for this, okay, so we take our f of x equal to x cubed plus 1, so y equals x cubed plus 1, y minus 1 is equal to x cubed, x is equal to the cube root of y minus 1, okay, and we're looking for f dash of x, okay, so that's going to be the cube root of, instead of y, replace it with x minus 1. Okay, now, so if we just shoot down to this other example down here, okay, so you're given a function, okay, the relation f of x is equal to x squared minus 4x minus 4 is a function with a domain x greater than 2. That's going to be important. Find f dash of x and write down its range. Okay, so looking at this particular quadratic equation, remember, to find f dash of x, what we have to do is we have to get x on its own, x squared minus 4x minus 4. Now if you look here, there is no way that I'm going to be able to just isolate the x. Every way I look at it, I'm going to be left with a y and an x on either the left hand side or the right hand side. Now in this particular question, it's important to note that this is where completing the square may be examined, okay? So that's the way you're going to be able to isolate x, by completing the square. So to complete the square, you halve the x coefficient, which is minus 2, you square it, and you add it on and you take it away. So y is equal to x squared minus 4x. So half of it is minus 2, square it, add it on, and then your 4, and then that's your 4 that was there already, and then take that 4 away again. Okay, y is equal to, so x squared minus 4x plus 4, so that's going to be x minus 2 by x minus 2 minus 8. So y is going to be equal to x minus 2 all to be squared minus 8. Okay, and so remember, I'm trying to find the inverse, so y plus 8 is equal to x minus 2 all to be squared. So x minus 2 is equal to the plus or minus the square root of y plus 8. Okay, so I'll come back to that plus or minus in a second. Remember, I got the square root, so it has to be the plus or minus version. Okay, so now I'm left with, bring over the minus 2 and it becomes 2. So